Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 2.7, Problem 8. This is Section 2.7, Problem 8. It says find the least common multiple for the numbers 315 and 450. Now, in some of the previous problems, you may have been able to look at it and see the answer, like when we had 9 and 12. I could see that it's 36. For this problem, though, number 8, these numbers have gotten big enough that you're not going to be able to look at it and guess at it. I mean, to guess would take a huge amount of trial and error, not worth even attempting. Smaller numbers you might be able to get away with it. This 315 and 450, you really need to go through the process, do the prime factorization, make the list, multiply it out. So let's start with 315. Let's find the prime factorization of that number. Because it ends in a 5, I can see that 5 will divide in evenly. I can't even easily tell how many times. It should be 63. So let me just divide it in off to the side here. 5 will divide into 315. So we'll start with 31. 6 times 5 is 30. 31 minus 30 is 1. Bring down the next digit, which is 5. And then 3 times 5 is 15. No remainder. It goes in evenly. So let's start with this. 315 is 5 times 63. So now the 5 is prime. That won't split up anymore. The 63 is not. It is 7 times 9. Now the 7 is prime. The 9 is not. So the 5 will come straight down. It won't split anymore. The 7 will come straight down. It won't split anymore. But the 9 can be split into 3 times 3. So now I have the prime factorization for 315. So underneath the 315, let me put the numbers in ascending order. I'll start with the smallest one first, which is 3. And it's actually 3 to the second power because it showed up twice. Then 5 is the next biggest prime, then 7. So that'll be the prime factorization for 315. 3 to the second power times 5 times 7. Now let's do the same process for 450. Well, this one starts off easier than the 315 did, even though it's a bigger number. I can see right away 10 times 45, and then I can start breaking down each one of these. The 10 will still split down a little bit further into 2 times 5. The 45 will split into 5 times 9. And now the 9 will split again. So the 2 is done. It'll come straight down without splitting. The 5 is done. It'll come straight down without splitting. The next 5 is done. It'll come straight down without splitting. But the 9 on the end can split into 3 times 3. Now all those numbers are prime. That's as far down as they split up. And again, I'll write that prime factorization under the 450. I'll start with the smallest prime, which is 2. Then I have 3 that shows up twice, so I'll write that as 3 to the second power. Then I have 5, so that's 5 to the second power because there's 2 5s. And that's it. Now that I have the prime factorization, the next thing you need to do is make a list of any prime that shows up in either prime factorization. So we have 2, 3, 5, and 7. Those are the primes that get used. 2, 3, 5, and 7. Now what I want to do next is consider the exponents for each one of those primes and take the larger exponent in each case. So the 2 only shows up in one spot. It's 2 to the first power. So the 2 in my answer here will stay to the first power. Next, the 3. 3 shows up in 2 spots. It's second power in both spots, so it's not that one is larger than the other. You just take second power. Next prime, the 5. 5 shows up in 2 spots. In one spot, it's 5 to the first power, and the other spot is 5 to the second power. Now, I want the larger of those exponents. Second power is larger than first power, so I take second power. And then finally, the last prime is 7. It only shows up in one spot, and it's only raised to the first power. So in my answer, it'll stay 7 to the first power. So what I do next is I multiply these numbers together. I'll multiply 2 times 3 to the second times 5 to the second times 7. Now, that'll be some good multiplying. So let me leave the 2 for a minute. The 3 to the second power I know is 9. The 5 to the second power I know is 25. And I'll leave the 7. Now, let me do 2 times, well, let's do 9 times 7. 9 times 7 is 63. And I'll have 63, and 2 times 25 is 50. So it'll wind up being 50 times 63. And now At that point, I'll probably multiply it out the long way. I know I can actually do it without this. 100 times 63 is 6,300, and times 50 would be half of that. So that should be, half of 6,300 is 3,150. Let's see if I get it right. So let's actually multiply it out. So let's go 63 times 50. Well, the 0 times 63, that's easy, 0. Then the next line down, I'll put in another 0 to hold my place. 5 times 3 is 15. Write the 5 from the 15, carry the 1. And then 5 times 6 is 30, plus 1 more that we carried. 30 plus 1 more is 31. And then I'll add those numbers. 0 plus 0 is 0. 0 plus 5 is 5. Nothing plus 1 is 1. Nothing plus 3 is 3. So it is 3,150. So my guess was pretty good. If I were doing this on a test, I wouldn't count on it. I'd actually write it out the long way. So we got an answer of 3,150. What that means is that's the smallest value that 315 will divide into evenly, and 450 will also divide into evenly. And again, the reason why that's important is if we had a problem that had fractions in the problem, and 315 and 450 were the denominators of those fractions, our lowest common denominator would be this number, 3,150.